Question: solution X and Y both have a concentration of 0.1 mol per dm cube. A fixed volume of solution X is added to a conical flask and solution Y is added from the burette into the conical flask. A titration is performed. So first of all, solution X is added, then solution Y is added. The diagram shows the pH titration curve for the acid-base reaction between the two solutions. We can see that initially it was at a higher pH and it decreases to a lower pH. Since it is at a higher pH, that means it must be an alkali. So solution X is an alkali while solution Y is an acid. Because of adding solution Y, the pH drops. And since the pH drops, therefore solution Y is acid while solution X is alkali. And for solution X, we can see that the pH starts from approximately 11. Since the pH starts from 11 instead of starting from 14 or 13, that means it is a weak alkali. And comparing potassium hydroxide with ammonia, we can see that potassium hydroxide is a strong alkali while ammonia is a weak alkali. So it would be ammonia. Then it drops to a value that is approximately 1. Since it drops to a value that is 1, that means it is between 1 and 0. Therefore it must be a strong acid. Therefore, comparing ethanoic acid with nitric acid, we can see that nitric acid is a strong acid, so it would be a nitric acid. But if the pH stops somewhere like 3, then it would be a ethanoic acid since it is a weak acid. But for now, since it ends at 1, so it would be nitric acid. So the answer would be A.